Good morning, everyone, and thank you for getting on our last virtual breakfast of the season. And today we have a great presentation with Dennis Pennington about why to calibrate your yield monitor. And we're hopefully just going to get into harvesting here soon, so very timely thing for us to talk about. And then, of course, after that, we will have our traditional weather report by Jeff. Phil went ahead and already pasted in our evaluation link into the chat. If you could please take the time to follow that link and fill out what you think about this presentation, and I know there's an area to give overall feedback as well. We would greatly appreciate it. All right, Dennis, you can take it away.
All right, good morning, everyone. Thanks, Monica. I appreciate that. Yeah, like Monica said, we are getting closer to harvest. The fall air seems to be has a fall feel about it, especially this morning waking up. But so as we're starting to head into the fall harvest season, it's time to start thinking about calibrating the yield monitor. And I'll try to explain why it's important to calibrate the yield monitor, and I'll go through an actual example where we had a farm where we thought he had the monitor calibrated properly when in fact he didn't really have it properly calibrated. So first off, why do we want to calibrate? Most important thing is to ensure that you're getting accurate data collection. We use the data from yield maps to make a lot of decisions, and we can use it to conduct on-farm research, create management zones, and a lot of farms are starting to use their yield data to write prescriptions to do variable rate technology. Fertilizer and lime, some are varying seed rates, some are using split planters to do different varieties in different sections of the field. So if you're going to use your yield monitor data to make any kind of a management decision, whether it be nutrients or anything else, you need to have good quality data that you're using to make that analysis. So first, let's start out with just kind of the basics of how a yield monitor works. First off, there's a moisture sensor, and this is in the clean grain auger usually on the right side of the combine, just usually mounted toward the bottom. And what this does is it's got a subsampler in here that as the grain is flowing up on each paddle, it'll grab a subsample and runs it across a blade that sends a voltage measurement back to the cab, and then that voltage measurement is converted to a moisture reading. So that's the first component of the yield monitor. The next component is the impact sensor. So this graphic here shows the clean grain elevator with the grain coming up with the paddles, and then it throws the grain across this impact sensor. And what this impact sensor does, this is what it looks like. And what it does is it measures the impact or the amount of load that's being hit by amount of grain. So as you can imagine, when you got in a low yielding part of the field, there's less grain impacting or hitting this mass flow sensor, and so therefore the amount of voltage that it sends back to the cab is lower. Now when you're in a field or in an area of the field where you have high yield, the amount of flow hitting this is much higher, so the amount of impact there is higher, and it sends a higher voltage reading back to the cab. So these are the two of the things that we need in order to actually calculate an actual on-the-fly yield. But remember that this is basically just equipment, and these are sending voltage readings that we have to calibrate and tell it at this voltage, this is the right moisture, and at this voltage, this is the right pounds of grain flowing through the combine. So calibration methods, each combine is different. You got to read the owner's manual. Everybody asks me, is there just a simple, quick, and easy way to do it? And every model of combine is different. Every make or manufacturer is different. But there are always good, clear instructions in the owner's manual, so make sure you read your owner's manual. Most of the newer combines have what they call an advanced calibration method. I don't know for sure how many are using it, but I think a lot of people are using the Wizard. I would definitely recommend using the advanced because that allows for multi-point calibration, and I'll show you why that's important in just a second. The Wizard will only give you a quick and dirty, and in the example I mentioned where I had a research plot at a guy's farm and we were harvesting corn, he told me that he's got the combine dialed right in, and when we did the calibration, we found out differently. Now, some of the older combines that have yield monitors have a built-in calibration curve where only one calibration or sometimes two calibrations is performed rather than being able to, you can't do the multi-point calibration. The display on one of those looks like this one here. This is off from a John Deere 70 series combine. And so you can see it's got two different flows, mass flow loads here. And basically you start combining, you tell it to start. And then as you're combining on the standard here, you want to keep this little triangle in the middle here as far as the amount of flow going into that combine, because you're trying to produce a standard flow going into the combine, whether you've got in an area of field that's high or low yielding, so that you can calibrate that sensor.
We do have a question here. What's considered an old combine?
That's in the eyes of the beholder, I'm afraid. So I guess when I say an older combine, it's a combine maybe that doesn't have a yield monitor. So maybe it's not an older combine, but just one that doesn't have it, or one that has this older method of calibration. There was a point at which they started doing these advanced calibration where they're doing multi-point, and it varies from every monitor in every different cab. So I mentioned there's a bunch of different things that go into calculating yield on the fly. Now, when you get all done harvesting, you get this really nice yield map with points on there, and you can look at the field and say, okay, this is where areas where I've got trouble spots. This is areas where it's yielding really good. And then you might want to think about managing it differently. Well, there's a whole bunch of different sensors and things that actually contribute to that yield. So the first thing is, number one there is distance. The way the yield monitor works, you can measure the amount of grain flow going across that mass flow sensor, but you got to calibrate that to what distance you're traveling over a specific time. So you have to calibrate for distance, and usually you start the distance calibration, and in this display here, you can see this DIST in the bottom. On this particular display, you'd press that button, and that would take you to the distance calibration. Usually you drive 300 feet and see it, and it'll tell you on the monitor how many feet it thinks it drove. You go out and measure how far you actually did drive, and you plug the number in, and that's how you calibrate it. The second thing is the moisture sensor temperature. That moisture sensor that's mounted at the bottom of the clean grain elevator is impacted by the temperature. If you're harvesting wheat at 80 degrees, the voltage that thing sends back to the cab is different than if you're harvesting corn at 40 degrees. So you have to calibrate that with what the current ambient temperature is there. The system can adjust for the different temperatures, but the reading that you're going to get is different if you're harvesting in the 80-degree weather versus the 40-degree weather. So you just have to calibrate that. Number three is the mass flow vibration. What this does is it says when the combine is running, you got the thresher engaged, headers running, you're at full operating RPMs, you let the combine set there, and it's vibrating, and it's kind of bouncing up and down and back and forth just from the action of the thresher. You want to make sure that in those conditions that mass flow sensor isn't sending voltage back to the cab. If it is, that's like noise in the system. It's going to offset what your actual yield is going to be. So that mass flow calibration is something that needs to be done, once per year, at least once per year, and it'd probably be a good idea to do it once before each crop. Number four is the moisture sensor, and that basically run grain through the combine. It'll give you what the current moisture is. Grab a sample of it and take it and get it tested somewhere where you have a known moisture, and make sure you take it to somebody that has like a calibrated moisture sensor. I bought one of these little handheld moisture sensors, and it is so variable that I wouldn't trust it. I would take it either at a grain elevator, if you got like one of those GAC moisture sensors at the shop, take it back there and run your moisture on there and calibrate so you're getting accurate moisture. Number five is the weight calibration. That's the one that we're going to talk about, and that's what most everybody thinks is the calibration. They don't think about any of these other things. Number six is the other settings, including the lag time, the header position, cut width, GPS offsets. The lag time is usually it's between 12 and 13 seconds. It's the amount of time when you start say your combine's on the headland and you start to engage into the rows of corn, or you drop your table and you start into the soybeans. That's the amount of time it takes for those soybeans to make it all the way through the combine and actually start hitting that sensor, that mass flow sensor. So it takes time for that to happen, and in 13 seconds, you're now 50 or 100 feet in front of where that was. So what that does is that gets your GPS setting correct so that way it lines up right on the headland. Your header position, I would suggest you can set buttons on the handle for your cut position and then to raise the header at the end. If you set them, what that does is when you hit the button to raise the header at the end, when you go to turn around, it stops logging yield points. If you get a yield map that has all the tails where you turned around every time, you're probably just manually raising the head on the end and then manually lowering it back when you start to engage the next pass for harvest. So use that the buttons for the header position, and then that'll eliminate those tails on your yield map. You got to make sure you plug in the correct cut width. If you change heads for whatever reason, make sure you set that up in the combine. And then the GPS offsets are just the position with respect to where the beacon is on the cab. Those are all the different settings that go into calibrating. Other than number 5, these can be done once per year. Number 5, the weight calibration, I'd suggest you do that at least once per year per crop. And if you're doing any like high moisture grain, I would calibrate at a high moisture, and then when it starts to dry down, gets to a lower moisture, then do a second calibration at the lower moisture.
We have another question.
Sure.
Does a lighter grain miss the sensor, so not a good monitoring, as this year may be a lighter grain?
So good question. Usually these paddles that bring the grain up from down at the bottom, they usually throw that pretty good against this impact sensor. So even in low yield situations, it should be hitting this. And now if you're talking light grain, like say low test weight, it should still throw it against this mass flow sensor. In that case, what you're going to do is this is just going to read a lower voltage. And so we just got to make sure that lower voltage then gets translated into a lower yield point recorded on the map. Now there are, on these paddles, there are, stock combines. These paddles are made from used tire rubber. So they take used tires and they cut them into rectangles and they bolt them to the paddle to make the paddle here. So you get some variability in the cupping on these paddles, so it does impact how it throws against here. And there are some companies out there that are making specifically exactly the same paddle, to try to increase the accuracy of throwing against this impact sensor. But that's, I've talked to a few guys that have them. They like them. How much does it increase accuracy? I guess I don't have a good feel for that.
And there's another one. If there are less rows available for a full header cut, does this affect the yield on your maps?
Yeah, so that's another good question. So say you get to a headland done and you've got, or getting to the end of a field and you've only got, half your header width. Some of the newer combines have sensors in there and they will automatically identify that, hey, you're only cutting 4 rows here. And it will automatically adjust that, but you can also manually go in to your display in here. It doesn't matter what brand you have, you should be able to go in here and say, hey, change my cut width for this pass back to whatever width it is. Now, if you got like a triangle shaped piece, and say you're cutting soybeans, that's going to be a little bit more challenging to get that accurate if it's changing as you go across the field. And that, what I would do then is in your yield map, in the end when you're done, go in there and either delete those points out or do some yield map editing at the end when you're done with that. All right, so how does this mass flow sensor work? And this is where we kind of got into trouble with one guy that thought he had it calibrated properly. So what this chart does on the left-hand side here is the grain, the mass flow. This is the amount of grain coming in the combine. So when you're in high-yielding parts of the field, the amount of flow coming in is really high. And so you would expect at high flow, that translates into a higher voltage output. And so as your flow increases, the amount of output increases. But what you got to do is make sure that this voltage reading matches the actual grain flow coming in. So here's an example where they're overestimating the yield, because with a 2-point calibration, they're calibrating along a linear or a straight line. Well, the response is not linear. So what you got to do is do calibrations that get points within this curve. And that's why doing the multi-point calibration is important. Now, it's different between combines. This curve is going to be different. The equipment's a little bit different. The voltage readings might be different. So it's not going to be the exact same from combine to combine. This will vary between crops based on the way the grain hits the sensor, and it's influenced by a whole bunch of other things, including grain moisture, test weight, the clean grain elevator, those paddles I mentioned. Operator behavior is something that's important. If you want to get good quality yield data, you want to have an operator that operates things smoothly. If you have somebody that's trying to hurry and going as fast as they can, and then all of a sudden they start to plug up and they jerk the stick back and they're slowing up, so they're speeding up, slowing down a lot, you're going to get these slugs through the combine, and you're going to have yields that the combine might think you're yielding 12 or 1,600 bushels to the acre. And then you got to, when you get your map out of it, at the end, you got to go through and do some cleanup and clean those points out of there. So try to be consistent with the way you operate the combine. You can speed up and slow down, but just try to do it more gradually rather than erratically. What we want to do is calibrate the multi-points to get accurate estimation along this curve. So there's a couple different ways that we can do that. There's the cut width method, where basically you change the width of your cut or your pass, how much is being fed into the header, but you go the same ground speed. So an example here could be quarter width, half width, 3/4, and then the full width. When you're doing this, you want to run a minimum of 3,000 pounds of grain into the grain tank. It doesn't matter how many you do. You just, whenever it's convenient to stop. Once you get beyond 3,000 pounds, then stop, auger it off into something where you can weigh it, whether you got a weigh wagon or a grain cart with scales, whatever, to get an accurate weight reading. You got to do this 4 times to get all 4 of these points. The other method that I think probably is a little bit more popular is to use different ground speeds. So you're using a full cut width, but you might be doing 1, 2, 3, and 4 mile an hour. Maybe it's 2, 3, 4, and 5 miles per hour to get your different points in here. And so the reason that this is important, I mentioned this example here where the guy thought he had this combine. He said, the last field I combined, my scale tickets matched up within like a 1.5% of what my monitor said. So I said, that's great, but for my plot, I want to make sure we get good, accurate data. Would you just be willing to work with me, and we'll calibrate it. We'll do the 4 different loads, weigh them, and just see how we're doing. So this is what we did. So we did the 4 different speeds, 4 different miles per hour, 1, 2, 3, and 4, to represent the different flow rates. And the monitor at 1 mile per hour, we ran the combine until the monitor said we had 3,293 pounds. At 2 miles an hour, we ran it until it said 41.58, and 3 mile an hour, 54.22, and so on. So then we weighed it in a weigh wagon, and this is what was actually harvested in each of those passes. So at 1 mile an hour, the monitor said we harvested 3,293 pounds, and we actually harvested 3,976. So it underestimated. At 2 mile an hour, it was almost right on the money. It was only 3 pounds off. At 3 mile an hour, it said we had 5,400 pounds when we only harvested 4,700. So it overestimated yield at 3 miles an hour. And then at 4 miles an hour, it overestimated yield again. If you do the difference, you subtract the monitor weight minus the wagon weight, and in 1 mile an hour, it was underestimating by 683 pounds, overestimating by 683, overestimating by 358. And at 1 mile an hour, so in low yielding areas of the field, we were underestimating the yield by 17%. At medium to high yielding areas of the field, we were overestimating by 14.5%. And then, at the very best areas of the field, we were overestimating by 9.5%. Now you might say, well, he said he thought he had this thing calibrated. Well, if you add the total up, the total pounds that the monitor said for these 4 calibrations was 16,993. What we weighed in the weigh wagon was 16,635, only a 358 pound difference, or 1.5%. So he was going off from this, which is what the calibration wizard will give you. The calibration wizard will get you this close overall. But if you want to know your yield at low and high and be accurate in those areas, you got to do this 4-point calibration. This is a perfect example of why doing the multi-point calibration is important, because 1.5% or 1.7%, that's not bad. I'd be happy with that, even if I'm doing research out there. If my monitor is 1.7% off from the actual yield, that's good enough. But I'm not happy with being 17% off, or 14.5%, or even 9.5%, for that matter. So it's important to make sure you calibrate to improve accuracy and precision, especially if you're using this data to make any kind of management decisions like variable rate inputs. You got to make sure you plan ahead so that you have access to some way to weigh it, and get your moisture, a place that you can take your grain to get an accurate moisture reading to calibrate. But we use these combines to conduct on-farm research, and we're making decisions on what we're going to do next year on the farm. So if you're going to do that, you probably better be using or making your decisions with good data. That's about all I had to cover, but I'd be happy to take any other questions if anybody has any.
Just a reminder that the link for the evaluation is pasted in the chat box as well. So if you could please click and follow that link, we would appreciate it.